Gut. Danke. Guten Morgen alle. Es freut mich sehr, dass ich endlich hier bei W-JAX in München kommen könnte. Und jetzt auf Englisch. Just a few things to help you be more here, be more present. Here's how you can find me. This last link includes notes for this talk, including references to articles and books and so on, which means you don't have to worry about taking photographs of slides. There won't be any. This is the only one. It also means that you can just relax and be here. But if you'd like to ask a question, and I will somehow leave time to answer them, then you can do that by visiting menti.com, putting in the code, and just putting in a question anytime you like. Any questions that I cannot answer here, I will answer eventually online, I promise. Okay, so the title this morning is Programming is the Easy Part. I want to say the most important thing up front. I don't mean it in that way. I don't mean it like programming is the easy part, therefore we don't have to worry about it. In fact, I'd like to spend about half my time this morning talking about how to become better at programming. But I don't want us to stop there. So when I say that programming is the easy part, it's easy compared to the other stuff. At least that was my experience growing up as a programmer. I like to tell people that I keep this hair in part so that programmers will at least give me the first 15 seconds of attention before they decide that I don't know what I'm talking about. It's a way to help get the conversation started. And when I work with teams, when I work with individuals, most of the time we sit down and we start with a programming problem or a programming exercise or something about programming, design, testing. And usually after between 1 and 2 hours, I ask a simple question or I make a proposal, and then we find out that the real problem, the real reason that we are having this conversation, that we are working together, goes beyond the issues of programming. But before I go there, what do I mean by programming is the easy part? So what's easy about it? I feel like programming is relatively easy to, and I'm going to use this term, forgive me, master. And I don't mean master quite like this, but you don't really have to do that much in order to perform better as a programmer than most of the people around you. It's a bit of a sad fact. We were having this conversation last night about, I was talking with a non-programmer friend of mine who is a mathematician, so she is technical, just in a different field, and trying to explain to her what it is that I do with programmers, because it seems a bit strange. When I sit down to write code with my wife, which we do very occasionally, I find that there are some things that I need to explain to her because she doesn't know the programming language that we're working with, or she's not used to the typical programmer's workflow of how to work with tools. But there are some things that I normally need to explain to the professional programmers I work with that when I start to explain it to her, she has this blank look on her face, and she patiently waits for me to stop. And then she looks at me and asks the question, well, of course, why did you even need to explain that? How could it be any other way? So part of the actual programming part is not as difficult as we like to make it out to, and yet we spend a whole lot of time and energy focusing on that. And so I have some suggestions for how you can master programming, or at least master it enough to really stand out among the people that you work with. Not that you want to make them look bad. I made that mistake. I started at IBM in Toronto in 1998. And I seemed to be fairly good at what I was doing, and I spent about 2 years trying to convince everyone around me to do what I was doing because I thought it would help them. And I found out that that didn't work. And then I spent a year quietly doing my job well, hoping that if someone was interested in what I was doing, and they liked the idea that I would go home every day at 5 o'clock and not feel stress about my job, maybe they would be interested, what are your secrets? And what ended up happening was that they mostly thought that I was trying to make them look bad. So I couldn't win. But what was I really doing? I think that one of the things that I notice with programmers is they have a bit of a lack of confidence. And part of the reason for their lack of confidence is that they look at the senior programmers around them. Maybe they have attained the level of architect, whatever that means. And they feel like I could never do that. Or it would take me, I'd never received the training that I needed to do that. Oh, I wish I had studied different subjects in university, or I wish I had had different kind of training when I began as a programmer, and they think I couldn't do that. You know, she is really good at this high-level architecture stuff. I could never do that. I guess she was born with it. Nonsense. Here's how you can learn how to do that. One of the ways that, and by the way, this is not the only way. This is one way that works. I find that one of the secrets to programming well is to become comfortable with evolutionary design. Again, not the only way, a way that happens to work really well. So what do I mean by evolutionary design? This means a willingness to allow the design to evolve. Okay, that didn't really explain anything yet. The idea is that the design is evolving and you are acting like the fitness function, or if you prefer this metaphor, you are acting like the God guiding the code. It's like the code is actually, the code wants to evolve on its own, and you are the one who decides that this code gets to live and that code has to die. And then the code gets fitter over time. Now, how do you do that? So how many people in the room have heard of Kent Beck's four rules of simple design, or 4 elements of simple design? Okay, good. Instead of giving you the long version, I'll give you the very short version, because really there's only 2 things that you need to worry about. How many people in this room have either seen or read Bertrand Meyer's object-oriented software construction book? 1,296 pages. I'm impressed. Did anyone actually read the whole thing? Very well. I think you can take that entire book and reduce it down to a few pages, except that I'm sure that he has a whole bunch of really good examples that help you understand deeply what's going on. All those issues of coupling and cohesion, the solid principles, any of that, I think we can reduce it to 2 basic ideas. Remove duplication and improve names. It sounds too good to be true, but I promise you, the book that I wanted to write but didn't write was showing how all these high-level design principles that we use in designing software are they reduce to a linear combination of remove duplication and improve names. So I'm not going to try to prove it this morning, but I'd like to illustrate how I think this works. So there's 2 parts. First, remove duplication and improve names. So you're writing code, and you notice there's some duplication in structure, there's some duplication in workflow, there's some literal duplication. The same 5 lines of code are in 10 different places. And you know from experience that if the same code is in 10 places, then when you try to change it, you will remember 9 of them, you will miss the 10th one, and there's a bug. It's not the only way bugs happen, but it's a good way that bugs happen. Very common one. And so when we remove duplication, part of what we are doing is reducing the number of places that we need to change when we need to change something. That sounds good. That sounds like that might be helpful. But when you remove duplication, what you're doing is you're creating something new in the system. You're creating a new container of some kind. It could be a variable, it could be a class, it could be a function, it could be a method, a namespace, a package, a module. It depends on which paradigm you're using and which language you're using. The words are different, but the ideas are the same. They're all boxes. There used to be 5 things that look the same. Now you take those 5 things, you put them together in one box, and everyone goes to the same box to use that thing. So far, so good. What you've done is you've reduced the number of things that you need to change. However, when you create a new structure, a new container, variable, method, function, class, package, I don't care what it is, then you have to give that thing a name. This is a new thing, it needs a name. Well, if you want, you could just write a lambda expression, but if your code is nothing but anonymous lambda expressions, you have a different problem. So you have to give the container a name, and we are programmers, and we are not very good at naming things, right? I won't even use the old joke. You know the old joke. You can just pretend that I told it. So we're not good at naming things. And that means that when we give something new, when we create something new and then we give it a name, the name is probably not very good. And then you do something strange. You start to explain that code to somebody else. And you use words that are different in your explanation than the words that are in the code. So one of the things you could do is follow the simple rule of type what you say. if you need to use different words to explain what the code does, then maybe you could introduce those words into the code so that the next person can just bypass your brain and read those names in the code. Wouldn't that be helpful? And I actually have a model for improving names. Arlo Belshi also has this nice 8-stage development or 8-stage evolution of names that helps you essentially go from nonsense names all the way to intention-revealing names. His model is more precise than mine, but we have the same idea. That we don't sit there for 15 minutes trying to think of the perfect name for this class before we write it. That we write something down, and then every time we look at that code, we try to make the name a little better every day, a little better every week, until gradually we agree that this name is good enough. This name will last for a few years. Great. Now, what happens when you name things better? When the names are clearer, when the names are convey intention or convey meaning better to the readers of the code? Well, it turns out that when you name things better, and especially if you name things a bit more honestly and a bit more precisely, patterns in the names suggest patterns in the design. You start to notice that the same word from the technology, from your technology domain is the same. So you start to notice that the word persistent is here in 6 different places. Or you start to notice that the name customer is here in 4 different places. And maybe they're scattered throughout the code. So when you look at the patterns in the names, you can follow a simple rule that says that names that are related to each other should be closer together, and names that are not related to each other should be farther apart. We call this cohesion. And if you follow this rule, then what slowly happens is that responsibilities in the code base start to move and gather in a sensible place. Related code moves closer together, and unrelated code moves farther apart. When related code moves closer together, then you're increasing the chance that if I have to change this part of the code, then most of what I change is in the neighborhood. So it's easier to change all of it. It's easier to notice that these 6 things are the same in some way, and if I change one, I should change them all. It's also easier, by the way, that when you notice that this part of the code has to change, you don't have the risk that you're changing unrelated things at the same time, because the unrelated stuff has moved over there. So when you change this part of the code, you can feel a little bit more confident that you're only changing the parts that need to change. So again, we call this cohesion. Similar things are closer together, different things are farther apart. Now, what happens when you do that? After a while, you start to notice that from many points of view, these 6 related things, I could treat them like one thing. So I don't need to know the details of everything that's going on here. I can treat this as one thing in the way that it interacts with the code nearby. We call that abstraction. That's just hiding details. Senior programmers like to use the word abstraction, but if you ask them what they mean, they don't have a good definition. Abstraction is simply hiding details. That's it. That's the whole thing. There's nothing else to abstraction. It's hiding details. Some abstractions can be helpful if you hide the details that don't matter, and some abstractions are bad if you hide details that are important. But the goal is to hide details so that I can look at this code and treat it like a single thing. Now imagine that you're looking at code, a few thousand lines of it, and suddenly 90% of that code disappears into the background, and what's left behind are the few key parts that the outside world actually cares about. When you use a chair, you don't care how the chair was made, you just care that you can move the chair to here, sit down, and you don't fall. That's the interface of chair. And so the only people who care about the details of how the chair was made are the people who make the chairs. Anyone who uses it doesn't care. So now imagine 90% of the details disappear. The only things that you see are the parts that you need to know in order to use that part of the code base. And suddenly, you're not distracted as much as you were before. Suddenly you can see patterns, bigger patterns, higher level patterns, patterns that you couldn't see before when you had to look at all 2,000 lines of code. But what happens when you can look at those higher level, when you notice those higher level patterns? You see higher level forms of duplication. And now we're back over here to removing duplication. So when you remove duplication, you add structures to the system. You have to give those structures names. We're bad at naming things, so we slowly have to make the names better. And as we make the names better, code moves closer together that should be together, farther apart that should be far apart. and it's easier to introduce abstractions. Those abstractions make it easy to ignore 90% of the code while you're looking at this part of the system. And suddenly, you can see higher level patterns. And you'll notice forms of duplication at a higher level in the system. And then you're back to removing duplication. So then you introduce bigger containers. You give them names. You make the names better over time. 90% of what's left disappears into the background. And now you see higher level forms of duplication. So you remove those, and you just keep going back and forth until you get to the entry point of the system, and there's nothing left to do. And I would argue that the 1,296 pages of object-oriented software construction can be reduced to this basic idea. Now, the details are tricky, and it requires practice. And that's why evolutionary design, for me, is so important. I don't really care about, OK, so it's just us in here, right? We're not going to be talking to managers and VPs and executives, that kind of thing. It's just going to be us programmers for a while. I don't really care that much that evolutionary design allows us to deliver features sooner. I mean, I care as an investor, maybe, and I care about it deeply when I'm talking to the people who might hire me. But when I'm talking to you programmers, what I'm really interested in is making things easier for you. And practicing evolutionary design allows you to make progress now, to write code confident that even if you don't know everything that needs to be done, even if you don't know exactly how to design it yet, you can start now, and then over time, you can improve the design of the code a little bit every day so that when you have to build the next feature, it's not so expensive to build. You avoid that unfortunate thing that happens on many projects where after 6 months to 3 years, all the senior developers get together in a room and have that uncomfortable discussion where they ask, should we throw it away and start again, or can we keep going? Because they've painted themselves into a corner. They've designed themselves into the corner at the point where the things that they want to do are more difficult than they should be, and the things that they didn't know 3 years earlier, 2 years earlier are almost impossible. Where you have that meeting that says, yeah, we should be able to build this feature in 2 weeks, and then you look at the code, and in fact you say, no, more like 2 months. Evolutionary design helps you in feeling more confident about being able to add features to the system over time. But something else happens. Evolutionary design, and especially if you practice it with something like test-driven development, just one way to do it, you get to see examples. Thousands of examples, tens of thousands of examples of good code, better code, good code, better code, good code, worse code, good code, worse code. You get to see examples of how the code tries to evolve. And when it moves in this direction, then the next feature that you wanted to add becomes easier. And when it moves in that direction, it becomes harder. So you don't do that anymore, and instead you learn to do this. This is a little bit like learning a language. So when you learn a language, especially as an adult, but really also as a kid, you might read a little bit in advance. But mostly what you do is you start trying to speak sentences, and you look for the feeling, the image on their face that says that they understood you. And if they look at you and they kind of understood you, like you did with me this morning when I tried to speak German, then that's a test passing, right? And when you start this, the first thing that you try to do with a new language is just try to make tests pass. Just try to speak sentences that the other person understood. But then eventually they will look at you strangely, and you will explain to them what it was you were trying to say, and then they will give you a better way to say it, or they will correct you because you were incorrect, or they might just say, well, yes, that's correct, but nobody says it that way since the 1970s, say it this way instead. Or as you go along more in learning the language, you might then get into things like, yes, I understood you, but you wouldn't say it that way to your boss. You might say it that way to your friend, and you might say it that way to somebody on the street, but you would never say that to your boss, and you would never write it in an email. I know in German that's particularly important. So what you do when you learn a language is you use essentially this trial and error basis, this trial and error approach where you say things and you get feedback about what you said and then you change your approach. And yes, it's true, you can also read books on grammar and you can read books on style and you can use those to make better guesses about how to communicate with people, how to talk to people. But ultimately, what you're doing is going through thousands and thousands and thousands of examples of trying to say something and getting an evaluation, and then changing what you try next time, and then getting an evaluation, and changing what you say next time, trying and getting an evaluation. When you practice test-driven development, you do the same thing with design. By the way, that means that when you practice test-driven development or any other form of evolutionary design, you probably cannot learn it on your own. Probably what you need is to spend some time writing tests and refactoring, and then there are some changes in the design that you'll look at and say, yes, I like that, that's better. It's cool, I thought it would be designed like that, and even if I ignore that and just write tests, removing duplication pushes me in that direction, that must have been a good idea. But sometimes you do something and you're not sure if it's better. In fact, you think it might be worse. You're trying to apply some high-level design principle that you learned in school or that you learned from some trusted advisor, and then you try to do it, you try to evolve the code in that direction and it won't go. Or you try to evolve the code in that direction and it goes over here. That's when it's good to ask somebody. That's when it's good to know someone like me or any of the hundreds or thousands of people like me with 5 to 20 years of experience doing evolutionary design, because then they can point to your example and say, aha, you're ready for the next high-level principle. Or, aha, this is one case where the simple rules don't work as well. Try this instead. But when you do that, it works, in my experience, it works much more effectively than simply trying to learn modular design techniques from a book. So I remember when I started at IBM, they had this nice thing called the skills library. I felt very professional as a nice young programmer freshly out of school. Ooh, there's this library. So 20 years ago, you used to go into a room with e-books printed on paper, and then you would pull the e-book on paper down from the shelf and read it for some period of time, and you had to put it back because somebody else might want to read it. So I tried to read the books Object-Oriented Analysis and Object-Oriented Design. And Object-Oriented Design is this wonderful little book, except that it has these weird code examples in Smalltalk and Eiffel. How many people in the room have programmed in Smalltalk or Eiffel professionally? That's about as many, that's more than normal, actually. I guess as you get closer to Switzerland, there's a higher chance that somebody will have programmed in Eiffel professionally. But it would have been as effective for me to just take the book and bash myself over the head, because I really couldn't understand what it was telling me. But when I started practicing evolutionary design, I was learning design principles the same way that we learn a language. And that meant that, yes, it was slow for me to learn the principles of modular design, but as I learned each one, I could see hundreds of examples of how it worked, how it didn't work, when it worked well, when it worked poorly. And once I knew those principles, they were mine for life. They were here forever. And so that is maybe the primary reason that I teach test-driven development. It's nice to have the extra effectiveness. It's nice to have this sort of reduced volatility in the marginal cost of features. Ha ha, see, the programmer knows how to speak financial. Isn't that cool? But ultimately, what it does for the programmer, I think, is it helps you learn and really understand the principles of modular design. And then when you decide to make the jump from, say, object-oriented programming to functional programming, if you've practiced evolutionary design for a while, then you've had a chance to really understand something like, well, objects are simply cohesive collections of partially applied functions. So the constructor is the same thing as partially applying parameters in a function. What's the problem? And if that sentence went over your head, don't worry. Practice evolutionary design for a while. Give yourself a chance to learn the low-level principles. And in a few years, that will not only make sense, but you'll immediately go, ah, functional programming doesn't have to be that intimidating anymore. Cool, I'm going to start programming in Haskell today. All right, I would probably recommend Elm instead, but do what makes you happy. So I really think that programming is the easy part in the sense that learning how to program well, understanding design well, isn't magic. There are some people who learned it their own way, but for the rest of us who feel like, oh, I'll never learn that, or I'll never be that good at it, I'll never rise to the level of architect, I think if you just practice evolutionary design in some way and do it every day, then within 3 to 7 years, you'll probably be one of the most effective designers in your area, whether that's your company, your department, your business unit, whatever. I genuinely believe that everybody can learn to do it. The same way that everybody can learn to speak a language as long as they practice enough. But after a while, you start to notice that the problems that you have in programming, even if I just do this, woo, and you become master programmers in an instant, not all your problems will go away. And that, for me, is really the big thing. Let's check the time here. Ooh, wow, that went quick. Haha. Now, that says 11 minutes. That can't be right. I have 9:40. All right. It's a good thing I write the notes in advance. Two key things that you can do that will help your practice. One of them has to do with organizing the work, and the other one has to do with navigating the people. See, most of the time when I work with programmers, after the first 2 hours, I make a suggestion, and it turns out that the problem is not about the design, the problem is not about testing, the problem is not about the code, but it's about someone getting in the way, someone making a decision that contradicts what we want to do, someone introducing some arbitrary constraint, some artificial deadline that doesn't mean anything. Right? I love the sound of deadlines as they go past. So there's two things that I'd like to mention, but I don't have time to mention them both. So what I will do instead is I will say that organizing your own work is a place that you can start. Most programmers feel like they don't have enough time to, say, learn test-driven development, practice evolutionary design, to learn those design principles. I'm too busy actually doing stuff, I don't have time to learn anything. And that's nonsense for two reasons. The first reason is that time is not your problem. In the book Planning Extreme Programming, one of the chapters is called Too Much to Do. You have all the time that you need. The problem is that you have too much to do. Now, it sounds like I didn't really solve the problem, but in a way I did. Because if I tell you you don't have enough time, then you are helpless. Nobody can create time. At least the physicists haven't figured it out yet. But if I tell you that you have too much to do, suddenly there is a new option available. Figure out what you should not be doing, then don't do it. And that's the essence of Agile software development. Real Agile software development, the way we meant it to be. It's right in the Agile Manifesto, one of the principles. Maximizing work not done. Figure out the 70% of your work that you're doing right now and don't do it. It sounds impossible, but you can get started right away. You can start with something like the 2-minute rule. When somebody asks you to do something, if you can do it in 2 minutes, do it now. Otherwise, it has to go in your plan. Now, that sounds like I made the problem worse, not better, but trust me. When you keep track of all the things that people ask you to do and that you agree to do, the things that take longer than 2 minutes, you will realize very quickly that you are trying to do more than you could possibly do in your entire life. And so then you have to take stock and make a much more honest assessment of your capacity to do things. You will realize after about a month of trying to write it all down just how much you are trying to do, and you will not be able to do it all. And the earlier that you make peace with that and start doing less, the happier your life will be. And suddenly you will find that you, in fact, do have time to learn how to do your work better in a way that's lower stress, in a way that's easier for you. So I encourage you, there's one of the links in my notes is to something called the 2-minute rule. Start there. And if you find that that is a helpful little trick, then I encourage you to look at an idea called getting things done. I'm not trying to turn you into cult members. I'm just letting you know that getting things done is a good approach to organizing your work, and it might be a nice place for you to start. And what ends up happening is you start noticing all this spare capacity that you have, and you're able to recover it and use it to then make your work much less stressful. Now, this says 7 minutes. Can I really take 7 more minutes? Okay. I wanted to get everyone out to the coffee break by 9:43, but I failed, and I apologize. The other thing I want to mention, and by the way, for the questions that are here, I promise you I will answer them online, or if you want, find me out there, and I'm happy to answer as many questions as you'd like to ask me. So these questions aren't going anywhere. I promise I will actually do something with them. The other issue is navigating the people. And I can't turn this into a, teamwork and communication seminar in 6 minutes and 40 seconds. But what I can do is I can tell you that, so my father-in-law is one of those people who grew up as a kid and somehow intuitively knew how to make the other kids in the playground play the game that he wanted to play. And he made it seem like it was their idea. It seemed like he was born with it. I was not that person. I was the fairly stereotypical INTJ programmer. Don't worry, I don't actually believe in Myers-Briggs, but it's good to use that abbreviation. I was the typical highly analytical programmer who liked computers because they did what I wanted them to do, and these strange bags of meat had their own agenda and their own ideas, and I didn't know how to communicate with them. Until somebody taught me a trick that I could use to debug bad conversations with people. So that's the trick I want to share with you today. And you can use that as the starting point to improving your interactions with other people. If you've ever been in a conversation with somebody that ended badly, screaming, yelling, punching maybe, it depends on the context. Maybe it was in a design meeting, I don't know. Then you go into, you get away from the situation, go in the corner, pour yourself a glass of wine or something stronger if you like that, start crying, and then figure out what the hell happened. So here's one way to figure out what the hell happened. It's called the Satir interaction model, S-A-T-I-R. She was a family therapist, and she and her colleagues found out fairly quickly that you could apply her ideas of family therapy to organizational dynamics, that organizations act like families in very interesting and useful ways. So she talked about this interaction model. I'll give you a simplified version of it. Essentially, there are 4 parts to the model where you can try to debug the conversation and figure out what went wrong. Debugging tools are particularly useful for programmers. So rather than go through the whole model, I'd like to focus on the last part, because the last part contains something that I call the fundamental irony of interaction. I like these grandiose names because they sound good for marketing and they stick in the brain a little bit. You and I have a bad conversation, maybe we yell at each other a little bit. It's at work, so we keep it relatively calm. But I can tell you're angry, you can tell I'm angry, okay. What normally happens is that I object to the way you're acting. So I see you say things, do things, your face goes a certain way, your body sits a certain way, and I object to those actions. I'm going to call that your response. It's your response because you're responding to what I'm doing. And you're probably objecting to the way I'm acting, the way I'm speaking, the words I'm using, the tone of voice, the way that I'm standing, the way that I'm looking at you like this, or closing my eyes a little bit. So that's my response to what you're doing. And response is the end of this model. We get into trouble because typically what we do is we object to the other person's response and we try to change their response. Right? We say things like, stop yelling at me, or stop hitting me, or don't look at me like that. We focus our energy on their response, and here's the fundamental irony of interaction. The last 2 parts of the model are called significance and response. Significance has to do with interpreting what is going on. It has to do with answering the question, what is causing that person to say this to me this way in this context right now? What are they thinking? What are they trying to achieve? Why have they suddenly decided to lean back in their chair and cross their arms? What we're doing is we're interpreting what's happening. And that interpretation is where all the interesting stuff tends to happen. The path from interpretation to response is the path that is the most automatic, because it is the most deeply culturally conditioned. You learn how to respond based on your interpretation of what's happening from the moment you're this high and trusted adults tell you how to act. And what you do is you start forming these connections between interpreting what other people are doing and deciding how to respond. And because it starts from here, it's almost automatic, it's extremely difficult to change, and this is the most important part, it's perfectly rational. This is the hardest thing to keep in mind. The hardest thing to change about the way we interact with people is to assume that given their interpretation of what's happening, their response is perfectly rational. What I mean by that is that if I had the same interpretation, I would behave the same way. So now we have the fundamental irony of interaction. You probably want to change the way they're acting, but the way they're acting is the hardest part for them to change. Because once they've interpreted what's going on, once they've attached some significance to what's happening, their reaction is automatic, involuntary, and perfectly rational. Therefore, focus your energy instead on their interpretation. And there are some ideas in the notes for how you can get started. One of the simplest ones is the law of 3 interpretations. Very hard to use, but if you practice it, it gives you some great results. When somebody behaves in a way that you do not like, that surprises you, that makes you upset, try to sit and think of 3 different ways that they are interpreting what's going on that would lead to that reaction. Now, you might not be able to do that during the conversation. That's something you do when you're crying over wine in the corner, is to think, what are 3 different ways that they could have interpreted the situation that would lead them to behave that way? And if you can't think of 3, you're not trying hard enough. Keep trying. And after you get good at that, you'll start to be able to use it while the conversation's happening. And you'll not only be able to recover the conversation after it starts to go wrong, but after a few years of practice, you get to the point where I know you, I know how you're going to interpret this. I'm going to change the way I act. I'm going to change what I say to increase the chances that you'll interpret me the way I intend to be. And if you focus instead on that interpretation, then you'll find it much easier to interact with people. You'll find that almost like magic, it's easier to work with them, much less stress, everyone's happier, and then we can get back to the programming part that we'd rather be doing. Thanks very much for your time and attention. I'll be out there, and I promise I will look at these questions. I promise.